So we have been introduced to the whole concept of surds and then also onto the properties. Now we know the properties. So let's begin with some arithmetic operations. From there, we'll go technically into solving real problems or calculations under surds. So we begin with the arithmetic operations, starting with addition and subtraction in this particular video. Right. Now, for addition and subtraction, we can only add and or subtract surds which are alike or have the same form. Note, reduce first to their basic forms if they are not. So the first properties, even under addition and subtraction, we have the general properties, right? And then coming down to addition and subtraction, we have, I wouldn't even call it properties, but it's a form, general form. Let me put it that way. So the first one is when we have m square root of k, then we have n square root of k, which gives us into brackets m plus n square root of k. Why is it so? It is so because this is what? Like what terms, or probably of like forms. Because under the square root sign or the radical sign, we have k and k. So that's what we are looking out for, making sure that if the square roots have the same what numbers, constants or variables, then we can then go on to what? Add the multiples of the square roots. So when you say multiples, it's simply the number or the constant in front of the square roots. The same thing here, right? Why is it so? Because m is multiplying square root of k, even though we have the imaginary multiplication sign there. So it means that m is multiplying k. And then when it comes to the other side, you have n multiplying square root of k. So we are looking at the square roots. If they are the same, then we continue with our calculation. If they are not, don't tempt it. And the same thing is applicable for a subtraction. So addition and subtraction, we are doing them together, right? So that is why we have into bracket m plus n, the square root of k, meaning we are keeping one of the square roots values. So that is it. The same thing here for subtraction is the same thing. But for subtraction, bear in mind that it is not commutative. So if you are subtracting n from n, you should stick to that, and then the sign should also reflect. If it is positive, you don't need to bring the positive sign, but if it is negative, you have to. Now we are continuing to ask you to note that square root of 5 plus square root of 2, it is not equal to square root of 7. Why is it so? Simply because the values or constants under the square root signs are not the same. Hence, you can't do any of the arithmetic operations on it, especially when it comes to addition and subtraction. In other arithmetic operations, you can do the calculation of them, but for addition and subtraction, so you remember or you would realize that this method is the same thing when it comes to arithmetic operations and any of the topics that we have treated so far, or we would or will treat. So that is the idea. So now it means that you can subtract this square root of 2 from square root of 5 because they don't have the same values under the square root signs. It's as simple as that. Now with that understanding, now we can zoom into the calculation, the simple calculations under the addition and subtraction. We are saying that we cannot add or subtract square root of this and that, you know. So now let's come down to example 1, where we have a number of them, about 6 examples. Square root of, we have 5 square root of 2 plus 3 square root of 2. Since the square roots are the same, what do? We add what? The multiples or the constants. Let me put it that way. I just want to sound technical because we have learned them. So hence that's why I'm saying the multiples. So 5 and 3. These are the multiples, or better still, the constant that you are familiar with, simple English terms. So since square root of 2, square root of 2 are the same here, what do? We add this and that. That will be giving us 8 square root of 2. Now we have 3 here, and there's 1 in front here. Imaginary 1. We told you in front of the square root there's a multiplication. So 1 is in front. So 4 here, 1 here, making it 5 square root of 3. Here, that will be 2 square root of 5. The same idea just from here. Here, 9 square root of 3. 13 square root of 5. This one is subtraction. We are subtracting 3 from 5. That will be positive 2 square root of 2. Here, we have that's 4 here, and then there's 1 here, and 3 square root of 3. So it continues that way. It's as simple as that. So here, let's see if I can do that now. This example that involves a bit calculation. Now look at this particular question. 3 square root of 8 plus 3 square root of 200 plus 2/3 square root of 162. Now this involves a bit calculation. Relax, I am not going to write it down, but we are going to do it. You watch, because I want you to also actually write things down. Do this yourself. I'm going to guide you. Now first of all, let's deal with the terms individually. Square root of 3 square root of 8. If you are to deal with only the square root of 8 alone, we have what? 4 times 2. Why? Because 4 times 2 give us 8. Now, how did you even choose these factors, 4 and 2? Because in the previous lesson, I think I didn't underscore that point very clearly. I'm going to emphasize that here. That when dealing with a square root or surds, the number under the square roots, we are to find the two factors. Now, a number will have a number of factors. Now, for surds, our concern is on the highest perfect square. The highest perfect square, that set of factors, that's what we are looking at. For instance, for 8, we have 4 times 2. We also have another set of factors, which are 1 and 8, because 1 times 8 is 8. Then 4 times 2 is 8. So these are two sets of factors. Why do we choose this factor 4 and 2? Because 4 is a perfect square, right? A perfect square, and is the highest. If you take 1, 1 is also a perfect square. Why? Because 1 times 1 gives us 1. That is it. Now when you look at 4, which we chose it to be the highest factor, is because 2 times 2 will give us 4. And then we told you how to remove the square root from a particular number. So that is it. So we chose 4 times 2. Now 4, square root of 4 will give us what? 2. So that 2 multiply these 3, making it 6 here. So it means that this 4 is gone. So if this 4 is gone, then we are left with the square root of 2, which gives us this. The same thing is applicable to this 200. Give us 100 times 2. Then we look at the square root of this one, 10 raised to the power 2. So they cancel out, then 10 would remain. So this 10 comes to multiply 3, making it 30. We are still left with square root of 2, hence 2, square root of 2. The same thing is applicable here. We look for it. Then 9 comes here. Here, square root of 89 will give us 9. 9 comes outside here. Then we will divide 3, leaving us with what? 3. 3 times 2, giving us 6. We are still left with square root of 2, hence square root of 2. So it's as simple as that. I think from here, you know the way forward. So the same thing is applicable downwards, and then that will be easy. So pause the video, listen carefully, follow the lead, and do this. In the next one, we'll deal with multiplication and division. And then finally, the last topic under surds will end the whole episode on chapter 4. So thank you very much for watching. We'll see you in the next one. Bye for now.